In this video, I'm going to go over the answers to the first 6 questions of paper 1. Here is question 1. You can see it's worth 3 marks. We have a function and we know it's g of x equals 3x taken 1 over 4, where x is any real number. We want to find the inverse function g to the minus 1. Now we know that g of x gives you the y value, so all we need to do first of all is to write down y equals 3x minus 1 over 4. Now, the next thing we do is swap x and y. We then want to get y on its own, so first of all we'll get rid of the fractions by multiplying everything by 4. That gives 4x equals 3 minus 1. And then we'll take the minus 1 beside the 4x to make it 4x plus 1, and then that will equal 3y. And then we want to get y on its own, so we just divide everything by 3 or put it over 3. Now, we have two y's. This y at the top is the original output for function g. We've done something down here, and then we've got a new y. This is the output for the function g to the minus 1, which takes you back. Now, so our final answer then is obviously change this y here into g to the minus 1. And there it is, g to the minus 1 is equal to that fraction. Okay, next question. We have a function h of x is 3 times cosine 2x. We want to find the value of h dashed 3 pi over 4. Now, you need to find the derivative of this function, so we need to know what it is, and that's on the formula sheet given to you. There it is. So if you've got a cosine ax, the derivative f dashed x is negative a sine ax. So let's look at our function. Our function is h of x. There's a 3 in front, but we can leave that alone because the only thing that we're going to change is the cosine 2x, which is equivalent to cosine ax. So what we get in the next step is we get h dashed will be 3, which didn't change, but then we have to go minus 2 sine 2x. We can multiply the 3 and minus 2, and then there's an expression for h dashed of x. But the input is x equal to 3 pi over 4. We're working in radians, so we can put that in. So we have that. It'll have 2 times this 3 pi minus 4. Now this 2 and the 4 will cancel to give you 3 pi over 2. So you're going to have negative 6 of the value times the value of sine 3 pi by 2. Now there's no calculator on paper 1, so you have to devise a way to work out what this is. So let's just draw the sine curve. 0, 180, which is pi, and 2 pi, which is 360. Now we've got 3 over 2 pi, which is 1.5 pi. Well, there's 1 pi and there's 2 pi. 1.5 pi splits it in the middle, which actually comes down to 270. Now, how do we find the value there? We can see that it's going down to minus 1. So sine of this will be minus 1. So the next step is negative 6 times negative 1, which gives you the value 6. So this answer is h minus 1 of 3 pi over 4 equals 6. That was for 3 marks. Question 3. This time we have to find the equation of the line perpendicular bisector to the line joining these 2 points. Now, I can see that A, because the x-coordinate is 2, is to the right of B because the x-coordinate is negative 2. And also, it's 4 down, but B is 8 up. So I'm going to draw a little picture. There you go, it's something like that. It doesn't have to be accurate, but I do know that A is down and B is up to the left, like that. Now this is worth 4 marks, so it's quite a lot of work involved here to get to the answer. Now what do we want? We want the perpendicular bisector. Now bisector means we want to cut it in half and then draw a line that cuts it in half at right angles because it's got to be perpendicular. So there's the midpoint, and then we have a line that goes like that, and that's 90 degrees because it has to be perpendicular. Now, to get the midpoint, it's the average of the 2 points A and B. So that it's the point 2 from the first coordinate plus minus 2, and then half it because you want the average. And then the second one is minus 4 plus 8 divided by 2, and that will give you the midpoint 0, 2. So we've got a point on the line. The next thing we want to do is to calculate the gradient of AB. So the gradient of AB is 12 over minus 4. And how can I get that quickly? Well, gradient is the y change, which is minus 4 going to 8. If you're sitting at minus 4 and go to 8, that's a jump of 12, positive 12. Now, we put it over x, the x change is going from 2 to minus 2. So if you're sitting at 2 and you want to go to minus 2, you've got to go down, how many? 4, and that's why I've got 12 over negative 4. So we've got the gradient of this, line AB equal to negative 3, which means that the red line, that one we want, has to be the perpendicular, so we can say the perpendicular will be 1 over 3. How do we know that? Well, when you multiply 1 over 3 by negative 3, it has to equal 1, because perpendicular lines, the gradients multiply to give negative 1. So that will be that will be the perpendicular 1/3. So we've got the point, right? We've got the point, which was 0, 2, and we've got the gradient. So we use this equation, y minus b equals mx minus a. Let's plug the numbers in. There's your a and b up here, and there's your m. So let's just do that. Oh, yeah, m is that point. So now go y minus 2 is 1/3 x minus 0. You tidy this up, you get y equals 1/3 x plus 2, and that's the answer for 4 marks. Okay, let's go to question 4. Now, this one is about functions. Now, we have 2 functions. The first part of the question is worth 2, and then the second part's worth 3. So we've got a function that is 1 over root x, where x is bigger than 0, which it has to be because you can't have a negative number for x, because the root of x, root of a negative number, doesn't exist. Now, g of x is just a quadratic, and x is a member of the real numbers. We want to find the composition function h. So h is f acting on g. So let's do that first. So h acting on g is what we want. F acting on g is what we want. So for function f, the input is not x, it's gx. So we'll change it into this gx here. And the next step is to put that as the input. It's a new input. And if you look at what f is doing, it takes 1 and divides it by the square root of the input. The input is the bracket. So to get the answer for that, it's going to be 1 over the square root of x squared minus 2x minus 8. And that's the first answer. Now, part B, we need to find out the domain of h of x. Now, I've already said that we can't have the square root of a negative number. So this quadratic can't be a negative number. And it can't be 0, because if it equals 0, then we have square root of 0, and 1 over the square root of 0 is undefined, so we can't have that. So let's think about the values that we have for x for this function h of x. The denominator cannot be 0, that's what I said, because 1 divided by 0 doesn't work. So we know that it's got to be bigger than 0. It can't be equal to 0, because also if it equals 0, then, if it's, it has to be bigger than 0, I beg your pardon. So let's quickly, how do we solve this? Well, what we need to do is we need to think about when it equals 0. So we just say, let the left-hand side equal 0. Let's factorise it. It becomes x minus 4x plus 2. Now we want to find out the roots of that. We can find the roots. X is 4 or minus 2. And then all we need to do now is draw a picture. So there is the x-axis. That's where the roots will occur. It's going to have 2 roots, so it has to come down, turn and go up. And there I have 2 roots, negative 2 and 4. Now we want this to be, we want the value of x squared minus 2x minus 8 to be bigger than 0. Now you can see that we have to go to the left of negative 2, because as soon as we go to the left, we go up, and that's positive. And then the other one is go to the right of -4, which means we want to be bigger than -4, because when we go to the right, we still have to go up and not down. Between -2 and 4, we have to go down negative, and we can't do that for this question. So let's finish this by saying the domain has to be x is less than -2, and then x is bigger than 4. Okay, that was worth 3 marks. Quite a tricky one, that, but that's what you have to do. Let's move on to question 5. Okay, then this one is we have a function and we want to show that x minus 1 is a factor. Now, to do that, we're going to divide this by the factor, and if the remainder is 0, then it must be a factor. So let's do it like this by the method that you know. Synthetic division. We make a table like that, and then we put the numbers in from the coefficients in from f of x. So we have 2, -11, 4 and 5, and then because it's x equals -1, then we can put 1 in as a solution, and then all we do now is we just do the table. You bring down the 2 and you multiply by 1. You add, you get -9, you multiply by 1. You add, you get -5, you multiply by 1, and then you add, you get 0, and that's remainder 0, and that's exactly what we wanted to show. So remainder is 0, so x minus 1 is a factor of f of x, and that's what you should state. Now part B says we want to get this factorised fully. So we've got one factor. The other factor you can get from the coefficients here. So we can say f of x is x minus 1 times 2x squared minus 9x minus 5. And all you need to do now is to factorise this. Because it's pretty easy, it's going to be a 2x bracket and an x bracket. So there's x minus 1, there's your 2x bracket, there's your x bracket. The two numbers have got to multiply to give -5 and then add to give -9. That's the only way it can work out. So there is a full factorisation of f of x. Okay, this one, number 6. A ball is thrown upwards. So you imagine a ball is going up in the air and the height is given by this formula. We want the rate of change of the ball when it's thrown. Now, the rate of change means the rate of change of height with respect to time. So we're going to start by saying the rate of change is a measure of the speed of the ball and is given by the derivative h dashed of t. So we have h dashed of t, if we differentiate this, becomes 18 minus 2 times 3 is -6t, and then you reduce t squared to t. Now, that's when the ball is thrown, that's right at the start, so the time is 0. So when the ball is thrown, the time has to be 0, because that's what it's asking you to find out the rate of change. So all we do now is we just put in the rate of change of the ball has to be h dashed of 0. The derivative, that's this function, and we put 0 in because the time is 0. We get 18 minus 6 times 0, which becomes out to be 18 meters per second. Now, what does that mean? Because it says and also for this part, explain your answer in terms of movement of the ball. Well, if the ball's height is 18. Oh no, I beg your pardon. Sorry. I've got to go on to number 2 now. Right. So let's look at number 2. Sorry, part B. Find the speed of the ball after 3 seconds. I was ahead of myself there. Sorry about that. We've got t equal to 3, so we can just put t equal 3. The speed of the ball is h dash 3. 18 minus 6 times 3 is 18, which gives you 0 meters per second squared. Now you think about it. You throw a ball up in the air. It's moving. Gravity is trying to slow it down. Eventually it will stop. That means then, as the speed of the ball is 0, this shows that it has reached the highest point. And that's really what you want to say to get the full 2 marks there. Okay, that's it. That's the first 6 questions. Oh, sorry, the first 6 answers.